Node.js modules are the essential building blocks in a Node.js application, allowing developers to organize and encapsulate code for better maintainability and reusability. In this video, we will learn about the type of node modules, create a local node module, see how modules can talk with each other, access variables and methods declared in the other module. This video is a part of a series of videos I am making about Node. Please watch my video, What is Node.js, to understand the basic concepts of Node. Installing Node.js to learn how to install Node on your machine. And Node Version Manager or NVM to learn how to manage multiple Node versions on your machine. Writing and executing code in Node.js to get started with Node. I have the links in the description below. Alright, let's now understand Node modules. Node modules enable developers to break down their code or application into smaller, manageable units, each serving a specific functionality. By leveraging the module system in Node, developers can make two modules talk to each other, easily import and export functions, objects, or classes from one module to another, creating a modular and scalable approach to software development. We will understand it better with examples. Node.js includes three types of modules: local modules, core modules, and third-party modules. Local modules are modules created by yourself and stored locally. You can import them using the relative path. Core modules are included with Node.js and do not require installation. You can import them directly using the required command. Third-party modules are modules downloaded from package managers like npm. They are stored in the Node modules folder. We'll talk about all of these. Let's first start with the local modules. So in the last clip, we created our file app.js. That is a local module. Let me create another file logger.js. Put in the console.log statement in here, and this logger.js is another local module. So every JavaScript file in Node is a module. But that sounds pretty simplistic and frankly unimpressive. Well, Node behind the scenes does a lot. It wraps each file in a wrapper function and invokes it, and this structure makes it very flexible and powerful. Let me show the wrapper function behind the scenes which Node creates. So let's create a function log which takes in the message and inside does a console.log of the message. Let's also do a console.log of the arguments, which are the arguments of this function. Let's call this function passing in a test message module test. Let me go to the terminal and run node logger. And here we see the arguments to this function which start with 0. This one has only 1 and its value is module test. Okay, let me get rid of this code and just put in a line console.log arguments. What do you think will happen here? Let me run it. And as you can see, behind the scenes, Node has wrapped it up in the wrapper function, which has 5 arguments. Let me put the code back in. So this is how Node would wrap it up in a function with the first argument as an exports object, which currently is empty. The second one is the require object, which we will learn about shortly. The third one is the module object. You can see its structure. The ID, path, the exports parameter is actually the alias of the module.exports property and its other properties. The fourth argument is the file name of the current file with its entire path, and the fifth one is the current directory. Let me remove this console.log and output the __ dir name and file name and run it. And here we see the info. Let me remove the outputs. Using the let keyword, let me create a variable level which indicates the log level and assign it a value informational. Now this function log and this variable level and all the parameters of the wrapper function are local to this module, and the other module, for instance the app.js, cannot see it. Let me get rid of the code here. If we want the app.js to use the log function and the level variable, we have to export them, meaning making them public for other modules by assigning them to the exports object. Remember, exports is an object which points to the module.exports property. So let's say module.exports.level equal to level, and module.exports, and we can have a different name for the consumers who see them than the internal name, so logger, which points to the log function. So our exports object now has two attributes to it, level and logger. Going back to the app.js, the way we bring in the logger module is by using the require keyword. So constant log, require, and we refer to the module using its relative path, so /logger. If it was in a subfolder, we would have it included here. If in the parent, we would have it go one level up by using .. So let's bring the logger module. So what comes here is what we have put in the exports object. So the exports object is the top level API, which we store it here in the constant log inside our app.js module. Let's examine it by using the console.log, passing in the constant log. Run node app, and we see that it's an object with two attributes, level with the value of informational and the logger, which is the function log. Cool. Now we can use these inside. So let's first output the current value of the level, assign the log.level to error, output it again using console.log, and using the log.logger function, invoke the log function of the logger module, passing in logging message using logger. Let me clear the screen and then run node app. We see the previous value of level as informational, the changed value as error, and the output using logger.js log function. So this is how, using the exports object and the required keyword, we can have modules talk to each other and use the other variables, functions, etc. Now, the exports object is an alias of the module.exports. So we could remove the module keyword here, run node app, and we see the same results. Let me not export the level variable. In app.js, remove lines referring to it. Run node app again, and we see the output message again. Now since exports is an alias to the modules.exports, which is an object, as long as we are exporting an object, we can use it. But if we change the exports object to be a function, this would error, as we are changing the structure of an underlying object using an alias. Let me run node app to show it. And we see the error that log.logger is not a function. If we are changing the structure of the exports object, like here to be a function, we have to directly work with the module.exports object. So assigning this the log function, so now it is a function. In app.js, now what is returned is a function, not an object. We have to use it directly. So log is a function. Let me clear the screen, run it, and it works as before. The module.exports is very flexible. I can change it to be an array. Running node app now outputs the array. I can change it to be a string. And now it outputs the string. So it's very important to remember that if you're changing the type of the module.exports from an object to another type, then you cannot work with the exports alias, but you will have to work with the module.exports object directly. Let me change it back to the function. Now running it, we can verify that what's being returned by the export is a function. Also, using constant is a good idea. I could have used var here, and it still runs fine. But then, there is nothing stopping for someone to change its value later, say 1. And now, running it gives 1. But if we had kept it as a constant, that would have prevented someone from doing it, and would have received an error assignment to a constant variable. In this video, we first talked about the various type of node modules, created a local node module, saw how we can call the methods and variables of a node module from another node module. Thanks for watching.